Hello, welcome to Getting Started with the Intel Galileo. My name is Brett Statham. I'm a Microsoft Technical Evangelist. You can find me on the web at brettstatham.com or on Twitter at brettstatham. In this session, we're going to start out with an introduction to the Intel Galileo and what its capabilities are. Then we'll show you how to take your Galileo out of the box and get it set up and ready for its first use. And once it's ready, we'll write and run our first sketch on the Intel Galileo. And then finally, we'll wrap up with some next steps and see where to go from here. So to get things started, let's first learn a little bit about the Intel Galileo. The Intel Galileo is the first Arduino certified board. What's different about the Galileo from a regular Arduino is that rather than using the Atmel Atmega chips, the Intel Galileo uses a Quark system-on-a-chip. This is a 32-bit Pentium class processor and has 256 megabytes of RAM on board. However, it's still Arduino pin compatible, so if you have shields that you're using with an Arduino, then you can use those same shields and even the sketches and libraries that you have for them on your Intel Galileo board. That's the benefit of this board being Arduino certified. In addition to those Arduino headers, though, your Intel Galileo also has an Ethernet port. We've got an RS-232 jack that has a 3.5 millimeter jack that you can plug into. We've got a USB client that you can use to connect the Galileo to your PC and use that for uploading code to your Galileo. But there's also a USB host. That means that you can actually connect USB peripherals to your Intel Galileo. And in fact, there's even a mini PCI Express port on the back of the board. So you can purchase regular mini PCI Express boards, like Wi-Fi cards, and plug them into your Intel Galileo. Now, out of the box, your Galileo is going to boot to a version of Linux that flashed onto the ROM on the board itself. However, there is an SD card that you can use to boot other operating systems. For example, you might run a fuller version of Linux that has support for that mini PCI Express Wi-Fi card you plugged in on the back. Or, as we'll see in a later video, you can even run a version of Windows on your Intel Galileo. Great. Well, where can you get one? Well, there's actually two different versions of the Intel Galileo available at this time. The original boards, the Generation 1 or Gen 1 boards, are readily available from a variety of online sources, usually for somewhere between $50 and $80 US. Sites like Amazon, Mouser, Adafruit, and SparkFun all carry the Generation 1 boards. There is, however, another version of the Galileo called the Gen 2 board. Now, we're not going to cover the Gen 2 board in this session. However, at least for this video, most of the things we talk about here should apply to your Galileo Gen 2 as well. There are a few differences, though. First of all, you'll notice that the RS-232 connection has changed to a 6-pin header. That's going to actually make it easier to connect to it if you have one of those USB serial cables that you've used maybe for one of your other boards. The host connection for the USB port has also changed from a micro connection to a regular full-size USB host. That's going to make it easier to connect peripherals to your Galileo. Intel improved the resolution of the pulse width modulation on the board, and that's going to give you finer control over servos and motors. The serial input coming into the board can be directed over to the Arduino side, giving you hardware direct access from your Arduino sketches, and eliminating in many cases the need for software serial. The Ethernet connection on the Galileo now also supports power over Ethernet, so you can actually power your Galileo directly off the Ethernet connection. And then lastly, the range of input voltages has been expanded. On the Gen 1 board, you had to use 5 volts. However, it's very popular to power these boards off of batteries, and so the range of input voltages has been expanded on the Gen 2 board to make that easier to do. Lastly, there's a ton of great resources available on Intel's site to learn more about your Galileo and to get engaged with the community. So use the link on the screen and get started. So let's start things off with our first demo and our first look at the Intel Galileo. This is my Intel Galileo Gen 1 board. Now, just as a quick example, I'm going to drop a deck of playing cards on there. You can see that the board's just slightly larger than a deck of playing cards. But we mentioned that we've got our Quark system on a chip. That's that Pentium class processor, as well as 256 megabytes of RAM. And again, really important part of this board is these Arduino compatible pin headers. That's going to allow you to plug Arduino shields into the Galileo and program against them using Arduino sketches and libraries. It's really important. Now, in addition to that, again, we've got our Ethernet, power, USB client, and host connections over here on the side, as well as our power and SD card, where we can boot from a different operating system. And then also remember I mentioned that back on the back of your Galileo, we've got this mini PCI Express slot here. So you can actually go out and purchase mini PCI Express cards, for example, a Wi-Fi connector or adapter, plug it in here, and use it from your Galileo. So anyhow, that's the Intel Galileo Gen 1 board. So let's take a look at setting up your Galileo for use. As you open up the box that your Galileo came in, you'll find, of course, the Galileo. Then you'll also find a 5-volt power supply with a variety of different types of outlet connections for it. You'll also find the cable, and the cable is going to go from USB on one end, and that actually plugs into a jack on the power supply, and the other end is going to be the barrel connector that you'll use to connect power up to your Galileo. What you won't find in the box, however, is the micro USB cable that you'll need to connect your PC up to the USB client port on the Galileo for programming purposes. So make sure to track one of those down before you get started. The next thing you'll need to do is to jump up to the Intel website and download a customized version of the Arduino IDE software created specifically for the Galileo. In these videos, I'm going to be using Windows as the host operating system, but you'll notice that there are versions of the Arduino IDE software for Linux, Mac, and Windows, as well as over on the right-hand side, you'll see links off to other getting started tutorials for other host operating systems. When you download the Arduino software, you're going to be downloading a zip file. The first thing you want to make sure in Windows is that you unblock the zip file. And that's just a normal thing. Windows blocks files that it downloads from the internet for security purposes. And it then prompts you every time you try to use it. It says, are you sure that you want to use this file? So we can prevent those unnecessary security prompts by first unblocking it. Right-click on the zip file, go to Properties, and then in the Properties window, click the Unblock button, and then OK. The other thing you want to be careful of is that as you extract the zip file, you want to extract it to the root of the drive, or as close to the root of the drive as you can. The reason is that if you don't, you might exceed the maximum path length for Windows. The other thing is if you already have an Arduino IDE or another version of it for another board, it's not a problem downloading and extracting this zip. Just make sure to extract it to a different directory, and you're not going to overwrite any other version of the Arduino IDE that you have. You're finally ready to connect your Galileo. First, find the 5-volt power supply that was provided with your Galileo and its cable. Remember, you'll also need to track down a micro USB cable that you can use to connect your PC up to the Galileo. The first connection you want to make is the power. Go ahead and plug in the power, and at that point you should see the power LED in the lower left-hand corner of the board light up. Now remember that your Galileo is actually booting off of a customized version of the Linux operating system by default. So you want to give the board at least a minute or so before you try to make the rest of the connections. When you're ready though, go ahead and plug the cable from your USB port on your computer up to the USB client port on the Galileo. And when you do that, you should see the USB LED on the Galileo board light up. If this is the first time that you've connected the Galileo up to this host PC, you'll need to install the device driver for the Galileo board. Open your computer's management, and underneath the device manager, you should see that a device needs a driver. In this case, I've got the Gadget Serial v2.4 saying it needs a driver, so I can right-click on it and choose Update Driver Software. From there, I want to browse from a folder on my computer, and specifically, I'm going to go point to the Hardware, Arduino, x86 Tools folder that's underneath the directory where I extracted the Arduino version for Galileo previously. Make sure to turn on the checkbox to include subfolders, and then click the Next button. It should detect the Galileo driver. Go ahead and click the Install button if prompted, and when it's all done, you should see that your Galileo driver has been loaded. And underneath the ports now in your computer's device manager, you should see that your Galileo is listening on a specific COM port. In this case, the Galileo, and I know it's hard to read there on the screen, but is listening on COM 3. And that's important. I'm going to want to remember what COM port the Galileo is listening on. Now that your Galileo is connected, go ahead and open up the Arduino.exe from the folder where you extracted the Arduino software for the Galileo. When the Arduino IDE runs, we want to first make sure that it's pointing at the right kind of Galileo board. So from the Tools menu, under Board, select the Intel Galileo, not the Gen 2, unless, of course, you have a Gen 2 board. We then want to make sure that the IDE is pointing at the right serial port. So from the Tools menu, under Serial Port, select the serial COM port that your Galileo was listening on. We saw that in the previous step. Finally, you're going to want to update the firmware on your Galileo to make sure that it's running at the most current version. You want to make sure to do this initially as you receive your Galileo for the first time, but you'll also want to check the firmware periodically throughout its use. To update the firmware, open the Arduino IDE as we described previously and make sure that it's pointing at the right kind of Galileo board and on the correct COM port. Then from the Help menu, select Firmware Update. You'll be prompted to make sure that your Galileo is plugged into a reliable external power supply, so make sure that it is and then click on OK. You'll then be notified of the version of the firmware that's on the board as well as the firmware that it's going to be updated to. And as long as you agree, go ahead and click on Yes. You'll then see a number of prompts letting you know that it's going to take a few minutes for this update to complete. You may also hear some USB connect and disconnect sounds coming from your host PC as the firmware update processes. Finally, once it's all done, you should receive a prompt letting you know that the target firmware was successfully updated. So let's go take a look at setting up your Intel Galileo. Alright, well let's take a look at getting the Galileo set up for use. So you can see in the camera view over here that I've got my Galileo, and I've pulled in the power cord that was shipped with it, as well as I tracked down a micro USB connector that I can use to plug it into my PC. So the first thing I want to do is connect the power. And it's a little hard to see on this camera, but down here in the lower left-hand corner, there's a little power LED, so that should have just come on. And then remember that this Galileo is really going to have to boot off of Linux, so we want to give it a little bit of time before we try to actually use it. And in fact, down here in the lower left-hand corner, you can actually see it try to read from the SD card, and you'll see some SD lights flicker. So I'm going to go ahead and wait at least until that happens for me. All right, and there they just blinked. Okay. So at this point, I feel like I'm pretty ready to go ahead and plug this into my computer. That took, maybe about a minute max or so, maybe a little bit longer before the Galileo was ready for me. And in fact, I can also see that the USB light is already lit, and that's okay. Don't worry about the fact that it's already lit up, but I am going to go ahead and plug in my USB connection now. And in fact, as soon as I did that, we heard our host system, give me the good old USB device connected. So the next thing I'm going to want to do is go check the device driver. So on Windows 8, I can just simply right-click on the Start menu down here, go to Computer Management, and underneath the Device Manager, I should now, underneath my ports, see the Galileo. And in my case, it's actually listening on COM port 9 or COM 9. Now, if I didn't have the driver already installed, this would be showing up under Other Devices. In fact, you can see I've got a couple other ones that are missing drivers. And all I'd have to do then is right-click on it and go to Update Driver Software, and then I would go browse my computer and point to that folder where I extracted the Arduino software, and we talked about that back in the slide deck. Underneath there's the Hardware Arduino x86 Tools folder, and there's an INF file for the driver, and you'd go ahead and next on through that to get the driver installed. And when it was done, you should see the Galileo listening on COM 9 show up down there, or in your case it might be a different COM port. So now that I've got that, I can go ahead and launch the version of the IDE that I downloaded for the Galileo. So let's jump out to my C drive. I extracted to this Arduino 1.5.3 folder, and I'll, inside there, double click to run the Arduino.exe. In fact, I think we're done looking at the board for now. I'll go ahead and get the camera out of the way. And so here's the Arduino IDE. From the Tools menu, I mentioned that we want to make sure that we're pointing at the right kind of Galileo board. So I've got the Galileo Gen 1, so I'll pick that one. And that I also have it pointing at the right serial port, which in my case is COM 9. So I'll go ahead and pick that and then verify that it was in fact selected. And then the last thing I'd want to do is go to the Help menu and come down to Firmware Update. And again, confirm the prompt that it's plugged in. and it's going to go check the versions, and it's letting me know that I'm already at the current version. I've already got 1.0.2, but asking me if I want to go ahead and rewrite it, and if I wanted to, I could and just repeat the process, but I gave you some screenshots back in the slides, so I won't repeat the process here. I'm good for now, so I'll say no. And at this point, my Galileo is set up and ready to get started. Now that our Galileo is set up and ready for use, let's take a look at writing and running your first program or sketch on the Galileo. Before we write code though, let's take a look at the programming foundation that Galileo sits on. At the bottom of the stack is processing. Processing was developed by some researchers at MIT with the goal of helping artists and creative professionals use programming and technology as part of their creative efforts. Processing was based on Java. Then along came wiring. Wiring used that same processing IDE and programming model, but based it in C and C++, and used it as a way to write code for their microcontroller. When Arduino came about, they used that same wiring IDE and C and C++ language to write the libraries for Arduino. And because Galileo is an Arduino certified board, we can use the same Arduino IDE and programming model to create code for our Galileos. The programs that you write for your Arduino, or Galileo in this case, are called sketches, and that harkens back to the processing origins of this programming language. But inside a sketch, you're going to have, at a minimum, two important methods. The first is the setup method. That's going to be run for you once at the beginning of the sketch's execution. And usually you're going to put any code that only needs to run one time and that helps initialize the state of your variables and the various sensors and things that you have connected to your Galileo. Then the loop method is going to be called repeatedly. So whatever code you put into your loop is going to run over and over and over again repeatedly as long as the sketch is running. Now you can add other methods and other variables and things like that as you need to, but you need to have at least the setup and the loop methods. Once you've gotten your code written, you can upload it to the currently selected board by hitting the arrow button up in the toolbar of the Arduino IDE. And that's going to compile the sketch and then actually upload it through the COM port, in this case, to the Galileo. Your Galileo, because it's an Arduino compatible device, has a set of Arduino headers that you can use to access a variety of digital and analog pins on your board. Now in this case, we're just going to talk about digital pins. We'll talk about analog pins later. But there's basically digital pins 0 through 13, but you can also actually use the analog pins A0 through A5 as digital inputs as well. And basically, they're going to let you read and write digital signals, either a low or a high value. You first need to let the Arduino or the Galileo know the direction of the pin. Are you going to be sending voltages out, or are you going to be reading voltages in on that digital pin? So we use the pin mode method, and then we give it the actual number of the pin, 0 through 13 or A0 through A5, and then the direction, either output or input. So to configure it out for output, I'd use pin mode, and then the pin number, and the keyword output. Then I can write values to that output pin. I can use digital write with the pin number and then either the low or the high keywords to actually set the voltage on that pin to 0 volts if it's low or to 5 volts if it's high. You can also read voltages in from a pin. So I would use pin mode with the pin number and the keyword input to indicate that I want to read values from that pin. And then I can use methods like digital read to actually read the value from the pin and, for example, store it into a variable. There are also various power references on the board that you can use in the circuits that you connect to your Galileo. There's multiple points where you can get to ground, and then there's also a 3.3 and a 5 volt header that you can gain access to so that you can power the various things that your Galileo is connected to. You do have to be very careful though to make sure that you don't draw too much amperage. Maximum amperage across all pins is 800 milliamps, but it's actually less than that on a pin-by-pin basis. So you'll want to use the link on the screen there to learn more about the maximum amperage that you can pull out of your Arduino pins. If you need more power than that for your other circuits, you'll need to power them externally and then simply connect them to the common ground with Galileo and then hook them up to the various pins that you want to read. One common thing to use in these demos is light-emitting diodes, or LEDs. Now, Light-emitting diodes, or LEDs, are just a special type of diode. Diodes only let current flow in one direction. Because of that, they have a polarity. We have to know which way is the right way. So the side of the LED that connects to the positive voltage source is called the anode, and the side of the LED that's connected to ground is called the cathode. Light-emitting diodes, though, when you apply a positive voltage to their anode, are going to emit light, right? And you can get them in red and green and blue and a whole bunch of other cool colors and all that kind of stuff. It can be difficult sometimes, though, to figure out physically which leg off of an LED is the anode and which is the cathode. So on the slide there, I've got a few tricks. First of all, if you look top down on the LED, you'll notice a flat edge. And the flat edge is on the cathode side, the negative side of the LED. If you actually peer through the lens of the LED, you should be able to see two small metal posts. The smaller of the two is the anode, and the bigger of the two is the cathode, so you can match those sides up to the legs that are coming out. Now, when an LED is fresh out of the box, usually the longer leg is the anode and the shorter leg is the cathode. But if the LED's been used before and maybe those legs have been clipped, then you'll want to use one of the other methods up above. And then if you ever look at a schematic with an LED in it, the LED looks like a little triangle pointing towards ground. And the little bar that's at the end of the triangle is also on the ground side. So that would be the cathode side of the LED. And then one last thing that I want to talk about before we jump into our last demo here is a really cool set of tools called fritzing. And you can get fritzing from fritzing.org, either download it for free or even better yet, make a donation. And fritzing is used throughout the industry to create these really awesome diagrams. In fact, you've already seen some fritzing art in the slide decks previously when you saw vector versions of the Galileo board showing up for us. But with that said, let's jump into sort of the canonical Arduino version of Hello World, and it's the blink sketch. And so basically, we're going to take our Galileo, we're going to hook an an LED up to the digital pins on the board. We'll have the anode of the LED hooked up to digital pin 13, and coincidentally, right next to pin 13 on the board, there's a ground header. And so I can hook the cathode side of the LED right up to the ground. It gives you a real easy way to just plug an LED right into those two pins. Now, if this were a professional circuit, I'd want to maybe protect that LED with a current limiting resistor to help keep from burning the LED out with too much current. But for this quick demo, it's not going to hurt the LED at all to hook it up. And on the code on the right-hand side, I'm going to let it know that I've got a LED hooked up to pin 13, so that's going to be my LED pin. And then in the setup method, I'm going to tell it to set the pin mode for that LED pin, 13 in this case, to output. And that's going to let us write voltages to the pin. Then inside the loop, we can write to that LED pin a high voltage, and then we'll wait for 1,000 milliseconds or 1 second. And then we can write to that LED pin a low voltage. That'll pull it down to 0 volts. And then it can wait for 1 second. So when the voltage is high, the LED should be lit. When the voltage is low, the LED should be off. So it'll be on for a second, off for a second, on for a second, off for a second. And it's just going to loop repeatedly. So let's jump over and look at running the blink sketch on our Galileo. Alright, so I've got my Galileo, and it's still connected from the last demo, but you can see I've also added in an LED. And my LED has the anode and the cathode. Remember, the anode was that longer leg, and the cathode is the shorter of the two legs there. This is a brand new LED, so I know that's good and reliable. You could also peek inside the LED, lit the posts, and look for the small one is the anode, the large one is the cathode. Or you could also try to look top down on the LED and see the flat edge. Now on the Galileo, there's pin 13 right over here on that Arduino header, and then right next to it, and it's hard to see on this camera, is a ground pin. So what I'm going to do is take the LED, stick the anode in pin 13, and the cathode into ground. And I'll bend the LED back a little bit so you can see it. Now, that was pretty easy to do right now. As you get more into these, you might look into getting some breadboards and some jumper wires and some extra parts and all that kind of stuff. But a quick LED right into pin 13 and ground, making sure to get the anode into 13 and the cathode into ground is a pretty easy way to get started. So I'm going to go ahead and open up the Arduino EXE. And this is from that folder that I extracted with the Galileo version of the Arduino IDE in it. And you'll notice that a default sketch opens up with the setup and the loop methods already in place. But if I go to the File menu and come down to Examples, you'll notice that I actually have a whole bunch of built-in tutorial sketches that you can use. And in fact, one of them is Blink. So I'll go ahead and open up Blink. And you see here that it's using an integer called LED to store the pin number of 13. Remember, we hooked the anode of our LED up to pin 13. In the setup method, we then use the pin mode to tell it that pin 13 is going to be an output pin. And that's the only thing we're doing in setup. Then inside the loop method, we've got digital write to write pin 13 high, and then wait for 1,000 milliseconds or 1 second. Then we write pin 13 low, and then again, we wait for 1 millisecond, and then loop just loops. It just repeats. So I've got my sketch written. Of course, I could have typed that, but there's not that much code, and having it right there out of the examples is pretty nice. And so to actually compile and upload this, first of all, you want to make sure that from the tools, you've picked the proper version of your Galileo board, and that from the serial port, you have it pointing at the right COM port. As long as that's all good, though, you should be able to just hit the upload button and let it go. So it's compiled the sketch and is uploading, and down here I can see the transfer is complete, and over in the camera you can see the LED is blinking. Off for a second, on for a second, off for a second, on for a second. Now in fact, you may notice there's another LED right down here on the board. So there's actually an LED hooked up to pin 13, and that's pretty common on your other Arduinos as well. It's just there sort of as a utility LED so that you have something to play with right out of the box. So it really, in this case, I didn't even have to plug an LED into pin 13 up there. I could have just watched this little LED blink right down there. Well, hopefully I've demystified getting started with your Galileo. We've seen how to hook it up, how to get it ready to use, and how to write programs and run it on the Galileos. So where do we go from here? Well, I've got a couple of quick next steps for you. First of all, jump up to maker.intel.com and get engaged with the community. There's a ton of great examples and things for inspiration that you can find out about up there, as well as a forum that you can join into and talk to other makers who are working with the Galileo boards. And then in a subsequent video, I'm going to talk about the Windows Developer Program for IoT and show you how you can actually install a version of Windows on your Galileo and start programming it from within Visual Studio. So stay tuned for that. With that, again, hopefully you're excited. We took a look at what the Galileo was. We saw how to get it set up and ready to use, showed you how to write code and deploy it to your Galileo, and even gave you a few things to move on to next. So go forth, have fun with your Galileo, and I hope to see you in the upcoming videos.